To start explaining the process followed to solve the problem situation, we need to take into account the information given to us, which was the table that is shown on screen with the years of sales from year 1 to 10 and the respective number of sales per year. For point number 1 is asking us to find the closest function. We need to start creating our graph, selecting quantities of year and sales, putting it together to have a better understanding of the company actions. To have a clearer image, I chose the scatter plot. Then we personalize our table, putting a name to it and labeling the names of the axes. And we need to add a trend line to try on which model function fits the best to our given points. In this case is polynomial. And don't forget that to have a clear panorama, we need to add the function in R squared, which will be explained in a moment. As we mentioned before, the selected function was a polynomial. A polynomial function is a relationship that for each x value corresponds one of y, such as quadratic, cubic, or quartic, involving only non-negative integer powers of x. We can give a general definition of a polynomial and define its degree. The reasoning behind the selected function is because, as we can observe, the trend line goes along the graph and their points are the most similar to it. On the other hand, if we analyze R squared, we can observe that it comes to be 0.9941, which is the nearest value to 1 than the other types of graph, confirming with this that is the most similar to the original information with a cubic polynomial function in order to have a more precise answer.
Going back with R squared is a statistical measure that represents the proportion of the variance of a dependent variable that is explained by an independent variable or variables in a regression model. The closer to 1, the more fitable in the model we are trying to analyze. The parameter found in the case is R squared equals 0.9941, which means it's the closest value to 1. Therefore, there is a high level of correlation with the initial model.
For the third point that we need to answer, we need to replace the number of years in the function that we have found before. Even though, to have a more accurate result, we can make some changes in order option to see which exponent is the one that best fits the original graph. In this case, I will have the following table to compare both functions and observe which one is the closer to the original. The column highlighted with blue is the one that gives the closest numbers. For this reason, it is the one that will be used for the interpretation of the graph. Therefore, the chosen function was polynomial, even though during comparing the information from the given equation with power of 2, I could find out that some values tended to decrease more than if we increase the power of 3. By this, I concluded that the equation that fits the better the scatter plot graph is a polynomial function with power of 3 in order to have more accurate results. As we can observe, when substituting the given formula of the trend line, we can see how the values are very similar to the originals in the scatter table, even though some values have a little changes between them. This can have different meanings, such as an increase-decrease in sales in some years, or losses in the company, among other factors, but also in the difference of 0.0059 from the R squared can have an impact on the results, since R squared is closer to 1, meaning this that it is more precise. In order to have a better and more accurate prediction, more data could be presented. If data of more years were given to us in shorter periods of time, perhaps monthly, quarterly, and or more specific sales, it will be easy to compare the sales behavior between 2 years or could be analyzed from months or other specific periods of time.